A journey through time, the history of volcanoes. These majestic giants of nature with their fiery breath and destructive power have captivated and terrified humanity for millennia. They are more than just geological features. They are potent symbols of raw power, reminding us of the dynamic and ever-changing nature of our planet. But volcanoes are also creators, shaping landscapes, enriching soil, and ultimately contributing to the very existence of life on Earth. This article delves into the fascinating history of volcanoes, exploring their origins, their impact on the Earth's evolution, and their profound influence on human civilization. We will journey through time, from the fiery birth of our planet to the present day, uncovering the secrets of these magnificent forces of nature. Chapter 1. The fiery birth of our planet. The story of volcanoes begins billions of years ago, with the formation of our planet. The Earth, born from a swirling cloud of gas and dust, was initially a molten ball of rock. As it cooled and solidified, its internal heat continued to radiate outward, creating a molten core. This core, composed primarily of iron and nickel, is surrounded by a thick layer of semi-molten rock called the mantle. The Earth's crust, the outermost layer, is relatively thin and brittle, broken into massive plates that constantly move and interact. This dynamic process, known as plate tectonics, is the driving force behind volcanic activity. 1.1. The dance of plates. Plate tectonics and volcanic activity. The Earth's crust is not a single solid shell, but rather a series of massive plates that constantly move and interact. These plates, ranging in size from a few hundred kilometers to thousands of kilometers across, float on the semi-molten mantle. The movement of these plates, driven by convection currents within the mantle, results in three main types of plate boundaries: divergent plate boundaries. Here, plates pull apart, creating gaps that magma rises to fill. This process leads to the formation of mid-ocean ridges, underwater mountain ranges that are the sites of intense volcanic activity. Iceland, located on the mid-Atlantic ridge, is a prime example of a volcanic island formed at a divergent plate boundary. Convergent plate boundaries. At these boundaries, plates collide. The denser plate is forced beneath the less dense plate, a process known as subduction. As the subducted plate descends into the mantle, it melts, generating magma that rises to the surface, creating volcanic arcs. The Andes Mountains in South America, the Japanese archipelago, and the Aleutian Islands in Alaska are all examples of volcanic arcs formed at convergent plate boundaries. Transform plate boundaries. Here, plates slide past each other horizontally. While transform boundaries are not directly associated with volcanic activity, they can trigger earthquakes and influence the movement of magma along other plate boundaries. The San Andreas Fault in California is a well-known example of a transform plate boundary. 1.2 hotspots, a plume of fire from within. While most volcanic activity occurs at plate boundaries, some volcanoes are formed by hotspots. These are areas within the Earth's mantle where plumes of unusually hot magma rise towards the surface. Hotspots can pierce through existing plates, creating volcanoes that are not associated with plate boundaries. The Hawaiian Islands are a prime example of a hotspot volcanic chain. The Hawaiian hotspot has been active for millions of years, creating a chain of volcanic islands as the Pacific plate moves over it. The youngest island, Hawaii, is still being formed by active volcanoes, while the oldest islands in the chain, such as Kauai, are now extinct. 1.3. The volcanic engine. Magma and eruptions. Magma, the molten rock beneath the Earth's surface, is the driving force behind volcanic eruptions. As magma rises towards the surface, it experiences decreasing pressure, causing dissolved gases to expand and form bubbles. This process can lead to explosive eruptions, where the pressure of the expanding gases forces magma to erupt violently. The composition of magma plays a significant role in the type of eruption. Magma rich in silica, a common component of rocks, is highly viscous and tends to trap gases, leading to explosive eruptions. Magma with lower silica content is more fluid and allows gases to escape more easily, resulting in effusive eruptions, where lava flows slowly out of the volcano. Chapter 2. Early Earth. Volcanoes and the genesis of life. Volcanoes played a crucial role in shaping the early Earth. Their eruptions released vast quantities of gases, including water vapor, carbon dioxide, nitrogen, and sulfur dioxide, forming the first atmosphere. This atmosphere, unlike today's oxygen-rich environment, was likely a toxic mix of gases. However, volcanic activity also contributed to the creation of the first oceans. As water vapor condensed, it rained down on the Earth's surface, filling the low-lying areas and forming vast bodies of water. Furthermore, volcanic eruptions released minerals and nutrients that were essential for the development of life. Early life forms, likely single-celled organisms, thrived in the hydrothermal vents associated with volcanic activity. These vents provided a source of energy and nutrients, allowing life to flourish in the harsh conditions of the early Earth. 2.1 The first atmosphere, a toxic brew. The early Earth's atmosphere was vastly different from today's. It was a thick, toxic brew of gases, primarily composed of carbon dioxide, nitrogen, and sulfur dioxide. Volcanoes were the primary source of these gases, spewing them into the atmosphere in massive quantities. This early atmosphere was devoid of oxygen, a gas that is essential for most life forms today. The lack of oxygen meant that the early Earth was a very different place, with a much harsher environment than we experience today. 2.2 The birth of the oceans, a wet and wild world as the Earth cooled. Water vapor in the atmosphere condensed, forming clouds and rain. This rain, falling onto the hot surface of the Earth, created vast bodies of water, forming the first oceans. These early oceans were likely acidic and hot, with a very different chemical composition than today's oceans. However, they provided a vital habitat for the first life forms, which emerged from the depths of these primordial seas. 2.3 The cradle of life. Hydrothermal vents and the origins of life. Volcanic activity also played a crucial role in the origins of life. Hydrothermal vents, found near volcanic areas, are openings in the ocean floor where hot, mineral-rich water is released. These vents provided a source of energy and nutrients, allowing early life forms to thrive. Scientists believe that the first life forms on Earth may have emerged in these hydrothermal vents. The extreme conditions of these vents, with their high temperatures and pressures, may have provided the ideal environment for the formation of the first organic molecules, the building blocks of life. Chapter 3. Volcanic landscapes, shaping the world. We know volcanoes have left an indelible mark on the Earth's landscape, creating some of the most awe-inspiring and diverse environments on the planet. 3.1 Mountains and islands. A legacy of lava and ash. Volcanic eruptions build up layers of lava and ash, gradually forming mountains and islands. The Andes Mountains, the Hawaiian Islands, and the Mount Kilimanjaro are just a few examples of the majestic landscapes created by volcanic activity. The Andes Mountains. This mountain range, stretching along the western coast of South America, is a prime example of a volcanic arc formed at a convergent plate boundary. The Andes are home to some of the world's highest and most active volcanoes, including Cotopaxi, Chimborazo, and Ojos del Salado. The Hawaiian Islands. This chain of volcanic islands located in the central Pacific Ocean is a product of the Hawaiian hotspot. The islands are formed as the Pacific Plate moves over the hotspot, creating a series of volcanoes that eventually rise above sea level. Mount Kilimanjaro. This iconic mountain, located in Tanzania, is the highest mountain in Africa. Kilimanjaro is a stratovolcano, a type of volcano characterized by its steep slopes and layers of lava and ash. 3.2 Calderas. The scars of violent eruptions. When a volcano erupts violently, it can collapse inward, creating a large, bowl-shaped depression called a caldera. The Yellowstone caldera in the United States is a prime example of this phenomenon. The Yellowstone caldera. This massive caldera, located in Wyoming, is one of the largest volcanic features on Earth. It was formed by a series of supervolcanic eruptions, the most recent of which occurred around 630,000 years ago. The Yellowstone caldera is still active today, and scientists are closely monitoring it for signs of future eruptions. 3.3 Lava flows and ash deposits. A cycle of destruction and creation. Lava flows can cover vast areas, creating fertile volcanic soils. Ash deposits, while destructive in the short term, can also enrich soil over time, making it ideal for agriculture. Lava flows. Lava flows, molten rock that flows out of a volcano, can travel for miles, covering entire landscapes. The 1980 eruption of Mount St. Helens in Washington state produced a massive lava flow that destroyed forests and homes. Ash deposits. Volcanic ash. Fine particles of rock and glass ejected from a volcano can blanket entire regions. Ash deposits can be devastating, burying crops, collapsing roofs, and disrupting transportation. However, over time, ash can decompose, enriching soil and creating fertile land. Chapter 4. Volcanoes and Human History. A story of fire and fear. Volcanoes have been a constant presence in human history, shaping our cultures, influencing our beliefs, and sometimes bringing devastation. 4.1 Mythology and religion. Volcanoes as sacred sites. Volcanoes have been revered as sacred sites in many cultures, often associated with gods and goddesses of fire, destruction, and creation. In Greek mythology, Hephaestus, the god of fire and metalworking, had his forge beneath Mount Etna. In Hawaiian mythology, Pele, the goddess of fire, was said to reside in the Kilauea volcano, Mount Etna. This active volcano, located on the island of Sicily, has been a source of inspiration and fear for centuries. The ancient Greeks believed that Mount Etna was the home of Hephaestus, the god of fire, and that the volcano's eruptions were caused by his forge. Kilauea Volcano. This volcano, located on the island of Hawaii, is one of the most active volcanoes on Earth. The Hawaiians believed that Kilauea was the home of Pele, the goddess of fire, and that her eruptions were a sign of her anger. 4.2 Inspiration for art and literature. The power and beauty of volcanoes. The power and beauty of volcanoes have inspired artists and writers for centuries. Caspar David Friedrich's painting The Wanderer Above the Sea of Fog captures the sublime beauty of a volcanic landscape. Jules Verne's novel Journey to the Center of the Earth takes readers on a thrilling adventure through a volcanic underworld. Caspar David Friedrich. This German romantic painter was known for his landscapes, which often featured dramatic and awe-inspiring scenes of nature. The Wanderer Above the Sea of Fog, painted in 1818, depicts a lone figure standing on a mountaintop, overlooking a vast expanse of fog. The painting is often interpreted as a symbol of the sublime, the feeling of awe and wonder that we experience in the face of nature's power. Jules Verne. This French author is best known for his science fiction novels, which often featured imaginative and daring adventures. Journey to the Center of the Earth, published in 1864, tells the story of a group of explorers who journey to the Earth's core through a volcanic crater. The novel is a classic of science fiction, and it continues to capture the imagination of readers today. 4.3 Natural disasters. The devastating power of volcanic eruptions. Volcanoes can erupt with devastating force, causing widespread destruction and loss of life. The eruption of Mount Vesuvius in 79 AD buried the Roman cities of Pompeii and Herculaneum, providing archaeologists with a unique glimpse into ancient life. The 1815 eruption of Mount Tambora in Indonesia caused a global year without a summer, leading to famine and disease. Mount Vesuvius. This volcano, located near Naples, Italy, is one of the most dangerous volcanoes in the world. The eruption of Vesuvius in 79 AD buried the Roman cities of Pompeii and Herculaneum, killing thousands of people. The eruption preserved these cities, providing archaeologists with a remarkable glimpse into Roman life. Mount Tambora. This volcano, located on the island of Sumbawa, Indonesia, erupted in 1815, producing the largest volcanic eruption in recorded history. The eruption caused a global year without a summer, as volcanic ash blocked out sunlight, leading to widespread crop failures and famine. The eruption also caused a major volcanic winter, which had a significant impact on global climate. Chapter 5. Volcanoes. Today, understanding and managing the risks today. Scientists are constantly monitoring volcanoes to understand their behavior and predict potential eruptions. This knowledge allows us to mitigate the risks associated with volcanic activity, protecting lives and property. 5.1 Volcanic monitoring. A network of sensors and scientists, geophysicists use a variety of techniques to monitor volcanoes, including seismic monitoring, ground deformation measurements, and gas analysis. These methods help to detect signs of unrest and predict potential eruptions. Seismic monitoring. Volcanoes often produce small earthquakes called volcanic tremors as magma moves beneath the surface. Seismic monitoring networks detect these tremors, providing early warning signs of potential eruptions. Ground deformation measurements. As magma rises beneath a volcano, it can cause the ground to bulge or tilt. Ground deformation measurements, using techniques such as GPS and interferometric synthetic aperture radar, INSAR, can detect these changes, providing further evidence of volcanic unrest. Gas analysis. Volcanoes release gases such as sulfur dioxide, carbon dioxide, and hydrogen sulfide as magma rises. Gas analysis, using sensors and remote sensing techniques, can monitor the composition and abundance of these gases, providing insights into the magma's composition and the likelihood of an eruption. 5.2 Evacuation plans. Protecting lives in the shadow of volcanoes. In areas with active volcanoes, evacuation plans are in place to ensure the safety of residents in case of an eruption. These plans typically involve identifying evacuation routes, establishing safe zones, and providing information and resources to residents. Evacuation routes. Evacuation routes are designated paths that residents are expected to follow in case of an eruption. These routes are designed to lead people to safe zones, away from the danger zone of the volcano. Safe zones. Safe zones are areas that are considered to be safe from the effects of a volcanic eruption. These zones are typically located far from the volcano and away from potential hazards, such as lava flows, ashfall, and pyroclastic flows. Information and resources. Residents are provided with information and resources to help them prepare for a potential eruption. This information may include evacuation plans, emergency contacts, and instructions on how to protect themselves from the hazards of volcanic activity. 5.3 Volcanic tourism. Balancing exploration with conservation. Volcanoes are also a major tourist attraction, drawing visitors from all over the world. Responsible tourism practices help to minimize the impact of visitors on these fragile ecosystems. Responsible tourism practices. Responsible tourism practices include minimizing the impact of visitors on the environment, supporting local communities, and promoting the conservation of volcanic areas. This can involve limiting the number of visitors, establishing designated trails, and providing educational opportunities to visitors. Conservation efforts. Conservation efforts aim to protect volcanic ecosystems and their biodiversity. These efforts may involve establishing national parks and reserves, restoring damaged habitats, and promoting sustainable land use practices. Chapter 6. The future of volcanoes. A constant force of change. Volcanoes will continue to be a powerful force on Earth, shaping landscapes, influencing climate, and reminding us of the dynamic nature of our planet. As we continue to learn more about these magnificent forces of nature, we can better understand their impact on our world and manage the risks they pose. 6.1 Volcanic hazards. A constant threat. Volcanoes pose a variety of hazards, including lava flows. Lava flows can destroy property and infrastructure, and they can be very dangerous to people who are caught in their path. Ashfall. Ashfall can disrupt transportation, damage crops, and cause respiratory problems. Pyroclastic flows. Pyroclastic flows are fast-moving currents of hot gas and volcanic debris. They can travel at speeds of up to 450 miles per hour and are extremely dangerous. Lahars. Lahars are mud flows that are triggered by volcanic eruptions. They can travel rapidly and cause significant damage. 6.2. Predicting eruptions. A constant challenge. Predicting volcanic eruptions is a challenging task, but scientists are making progress in understanding the processes that lead to eruptions. By monitoring volcanoes and analyzing data, scientists can identify potential signs of unrest and issue warnings to people in danger. Monitoring techniques. Scientists use a variety of techniques to monitor volcanoes, including seismic monitoring, ground deformation measurements, and gas analysis. Warning systems. Warning systems are in place to alert people to potential volcanic eruptions. These systems may involve issuing warnings to residents, closing roads and airports, and evacuating people from danger zones. 6.3 Living with volcanoes. A balancing act. Volcanoes are a constant reminder of the dynamic nature of our planet. They pose risks, but they also provide benefits, such as fertile soil, geothermal energy, and stunning landscapes. Living with volcanoes requires a balancing act, managing the risks while enjoying the benefits. Risk management. Risk management involves identifying and mitigating the hazards posed by volcanoes. This may involve developing evacuation plans, establishing warning systems, and promoting responsible land use practices. Sustainable development. Sustainable development aims to meet the needs of the present generation without compromising the ability of future generations to meet their own needs. In volcanic areas, this may involve promoting sustainable agriculture, tourism, and energy production. 6.4. The future of volcanic research. Unlocking the secrets of the Earth. Volcanic research is a rapidly evolving field. Scientists are constantly making new discoveries about the processes that drive volcanic activity. This research is helping us to better understand the risks posed by volcanoes and to develop more effective ways to manage them. New technologies. New technologies such as remote sensing and advanced computer modeling are providing scientists with new tools to study volcanoes. Interdisciplinary research. Interdisciplinary research, involving scientists from different fields, is helping us to gain a more comprehensive understanding of volcanic processes. International collaboration. International collaboration is essential for sharing data and knowledge about volcanoes. This collaboration is helping to improve our ability to predict and manage volcanic hazards. Conclusion. a journey through time, a story of fire and creation. Volcanoes are a powerful force of nature, shaping landscapes, influencing climate, and reminding us of the dynamic nature of our planet. They are a constant reminder of the forces that have shaped our world and the challenges that we face in living with these magnificent forces of nature. This article has explored the history of volcanoes, from their fiery birth to their profound influence on human civilization. We have journeyed through time, uncovering the secrets of these magnificent forces of nature and the impact they have had on our world. As we continue to learn more about volcanoes, we can better understand their impact on our planet and manage the risks they pose. By embracing a spirit of curiosity and collaboration, we can unlock the secrets of these magnificent forces of nature and ensure that future generations can enjoy the benefits of these powerful and awe-inspiring giants of the Earth.